Hey, thank you very much, and welcome to our webinar, CTE and STEM. It's time for a takeover. Appreciate you taking the time to come in and listen to this. Um, love to have people involved and interacting with us. And as we go through, we have some different resources for you at the end, but really love to see the engagement and happy to help with any more questions or directions after we get done with this presentation as well. So let's talk about how CTE and STEM are connected and how we can get these educational pathways to incorporate STEM concepts into every single pathway that are out there. Now, before we get started, if you have the time, and we'll show this at the end as well, but go ahead and take your phones out, scan this QR code. We want to start helping you to refresh your program. So if you are interested in that, if that's one of the reasons you came on to get more information about our RC Tractor, some other STEM products that we have, you can go ahead and scan this. It will allow you to connect with a local Realityworks account manager to help you kind of get more questions answered or to kind of see how it could help your program by using different products that we have. Again, this is a great resource for you to even to reach out to our account managers and say, here's what we're doing. What are the things and how could we incorporate other things to make our programs and CTE just really thrive? And we have a lot of different ideas and a lot of ways we can help in that world. So let's get started here. The question is that I always like to pose first and ask a lot of different people as I travel the country, work with a lot of different people is what is STEM? So if you ask that question, you will get a lot of different answers. Now, of course, we get the science, technology, engineering, and math portion of it, but what does it really boil down to? What does it really bring about? And what we can see is there are a lot of different ways that people will talk about it. So they bring it in and different ideas, different things of what it really entails, um, projects, activities, project-based learning, a lot of different ways that we have looked at it and answered it. But the real question is, what does STEM look like in CTE? STEM is something that can be so big and so broad, but if we boil it down, what does it look like in the world of career and technical education? Because I really think they tie in hand in hand. They work very well together. Sometimes we break it apart, and STEM is outside of that. It's its own world, it's interacting. Or sometimes it can be a look at a certain discipline, especially with the core classes, your science, your math classes, but really, how do you incorporate it and what is it and how can it be involved in all CT? Because that hands-on learning component, that challenging aspect of CTE, what does it do? How does it work is really important. Now, again, when you're driving toward STEM education through CT, there's different ways to help you. There's different things. Now, if you go onto the advanced CTE website, they actually talk through the pathway. CTE has a pathway: science, technology, engineering, mathematics. Bringing different pieces of it into CTE is very important because, again, it helps critical thinking and problem solving. That's a 21st century learning skill that we are looking for. It brings competition into your learning and helps grow skill and understanding. That competition is what really drives engagement, bringing a new learning format and arena into your classroom. So it doesn't matter what pathway you're in. If you're in the business management pathway, if you are in the health human services pathway, the health science pathway, the manufacturing pathway, you can bring and drive it into it because when you look at different STEM careers by career clusters, there are a lot of examples that you can look at in every single pathway that has STEM involved. So it doesn't matter what career cluster you might be in, there are different pieces in every single one of those different areas that could and has STEM careers involved. So that's where when we talk about STEM, I really think we should be talking about STEM as a CTE program, no matter what the path cluster or pathway is for you. Now, What does this do for us? Well, I think it really brings about a problem statement within STEM and CTE. When you ask this question, STEM and CTE education, really the statement is we need a roadmap of how they are connected and what should be used for teaching and learning to help students grasp STEM concepts. And so that is probably the biggest problem statement that I've heard is, okay, we have STEM out there, we have CTE. How do we marry the two? Or what does it look like? Uh, in the past, a lot of times it was, well, if it had some sort of robotic, then it would be considered a STEM. There's a time if you had a maker's space or a learning lab where you could do 3D printing, that was STEM. We kind of threw it out there and it's been a lot of different things. You probably could check a lot of different boxes off and call it STEM. But what I really see is that CTE needs that roadmap of how they're connecting the two and what they're doing about it. So in this case, let's look at some of the standards. So there are next generation STEM standards, and there's a lot of things like asking questions and defining problems. You could probably put that in every area of CTE. So you could bring it into your classroom and say, "Yep, we hit some of these standards." Developing and using models. Well, if you're in a health science class and you're using anatomical models, you're going to be, being able to hit that. When you're working with different types of agriculture type equipment and tractors or tractor parts and pieces. Well, you could be looking and saying, okay, what is the amount of pesticides or herbicides you're going to need for your field? Well, let's model that out. Let's look at what that is. That can be a STEM standard and kind of hitting some of those things. There's things like planning and carrying out investigations, analyzing, interpret data. All these different things really kind of help this understanding of what STEM is. Now, another model to look at that is talking first about the scientific method. Well, in the scientific method, that science piece of it, you do a lot of these things in your classroom already. You do things like observations, you question, you ask for students to, experiment and trial and error in that world. Now, what has happened is that we also have an engineering design process that has come and kind of mimics or mirrors this in a sense of identifying the problem, explore, design, create. Now, in some classrooms, we are already doing this, but instead of things like create or design or explore, we're hearing words and you're using verbiage like research, um, draw, do a prediction. You might be, hey, create is one where you might be looking at it and not thinking of it as a engineering design process, but really is when you're in a class and you're doing a sewing, you have to create that sewing project. But you also have to either design it or use a pattern, use a model, using different things that can also create the same kind of thing. So there's a lot of overlap um, in the method to the measurement. So again, how are you creating that measurement of what you're doing and really tying it in with that step? And so simple things like this and starting using the language, using the interaction of let's identify the problem here. All right. What is the problem? In a health science classroom, you do that all the time. I need to find out what is wrong with my patient. So then I'm going to explore things. I'm going to take their vitals and make sure I understand. Well, then, in the sense of design and create, it may not be that I'm designing something as a building as an architect book, but now I'm going to design the care path that they're going to be on. What are those ideas? And then create it. Well, I need to be checking in on them. I need to be giving them the working with these types of medicines. I need to be doing these types of tests. That's all a design to then create and then try it out. Okay, let's start working with that patient and see, does this help? Does that get them better? Does that help them in that world? So all of that is things that you could do. But if you're using different language, if you're looking at it differently, all of a sudden what you're doing in a classroom in a CTE pathway now can look very closely to what STEM is asking of us and what we can do in that world. So, again, how to use this design for your classrooms? Well, there's three different ways that I would say you can really kind of individualize it is bring individualized learning in. Have students start picking apart and finding ways to identify the different problems, they explore, design what they're going to do. Then bring it to a team situation. Have students bring their individualized thoughts together and now hone them in and say, okay, as a team, what would you do? And what problems or issues? That goes back to what we talked about earlier with the 21st century next generation is that critical thinking, that designing and asking questions, because I might look at it differently than another person. So that team aspect is big. And then finally, I would call it learning in action. The hands-on learning opportunities that your students get them doing and seeing, okay, what our ideas are now, can we actually try it out? Can we test those ideas and bring that action into learning? So at Realityworks, we've done a lot of surveys with a lot of educators asking the question, what is STEM to you? And so again, you can see some of the responses here when we talk about job titles and classes that they teach. So we went from different areas and we did a large research to see, okay, uh, middle school science teachers, uh, high school STEM teachers, CTE instructors, 2-year, 4-year post-secondary instructors. So we had a lot of different types of teachers that were involved. And then we would do a lot of, we did a survey asking them, would you call yourself a STEM or a STEAM teacher? Are you a general science and animal science, a generalist a teacher, makerspace? What are you? Now, and this included things that we got back from engineering, biotechnology, electricity, horticulture. So a lot of different types of teachers that would say they are STEM teachers and work in the STEM world. When we ask what's the number of students in your classes, students in STEM class range from anywhere from 5 to 10 to over 25 students in a class period or in a class STEM class. But on average, it's about a 25 students, or the largest amount was about 25 students. We also asked, what type of work do they do? And group work. And again, the 2 to 4 students in a group for that team learning seem to be the best amount in that world. And then we asked them how much time on task for different STEM projects. So the majority of them was about a 2-week time frame from the project from beginning to end in that STEAM or STEM world. And then what type of teaching model do you usually do and what's best? And again, you see project-based learning, you hands-on learning, small group projects, individual projects, and demonstrations. Those were the big ones. Those are the things that engage their students. Now, what does this kind of all come to is really this idea and an opportunity for you to start looking at different things like STEM methodology. How do you individualize the learning? So asking them statements. What do you know about the challenges? What don't you know, or maybe don't know that you want to learn? Explore, research the challenge, have them know what the challenge is, and what their expectations and what other resources they may have out there. Then bring it into that team learning. So the design and the create a lot of times can be in that team learning. Collaborate with lots of ideas that they just learned from that individualized learning. Create prototypes for their ideas, modify their plans, and problem solve their plans. And then get into the learning aspect of it. Try it out, make it better, and design again. So test your ideas. Test those things that are involved there. See what's going on there. Create competitions for best results and identify successes and failures. Now, with this being said, we go into solutions that we can bring into that world. So bring your some STEM products to you here that we can help as a company as Realityworks. So to begin with, I want to talk about our RC Tractor Pull Challenge. This is one that is focused on STEM, but it really hits a lot of different areas. It acts as a kind of a gateway into STEM by doing fun, challenging work involved with it. So in this case, our classroom set of tractors, we have 5 tractors. They all have an RC remote. They come with their own batteries, their own weights, and then their own gears, both pinion and spur gears. They also have a cover, so then you have 5 different colors. So there are 5 different tractors so you can use. We then also have a pulling sled that is also included in this product. Now, let's do a quick little demo here to talk through and show you the promo for our product here.
The RC Tractor Pull Challenge is a great way for students to explore tractor systems and multiple STEM concepts. As students assemble the 5 tractors, they can experiment and test different variables to see different pulling outcomes, such as weight distribution, gear sizes, and hitch height. Then, test out your tractors by competing in teams to see who can pull the most weight the farthest distance with the pulling sled. The included 5-lesson case-aligned curriculum teaches students STEM concepts, allowing them to collect and analyze data. Contact us today to learn more about the RC Tractor Pull Challenge and add it to your classroom.
So just a little video there showing the product itself and it in action, kind of how the usage of it is not just the tractor pull challenge itself, but all the engagement that can come from it. So in this case, the STEM concepts, scientific process is a big one, but torque and power, friction, force, balance and equilibrium, center of gravity, gear ratios, and then also data collection. And so bringing this into the classroom allows students to start learning things like gravity and force, the different weights on it, then also what kind of friction is being pull and push is included in that world. We also look at things like the gears and the gear ratio, the tire size, this it comes with different sizes of the tires, allowing you to have a lot of variables for students to work through and work with. Again, there's a lot of math and science working through the physics of it, working through the math equations on what the different pinion or spur gears are, how much torque that has, and what that does, along with things like simple machines and what variables are included there. All these features of this allow you to gain and bring in very in-depth STEM concepts into multiple different types of classrooms. So it might be your CTE generalist or that principles class of CTE. It might be for an ag class. It might be for some engineering type classes that you could bring these into. A lot of different variables there for you to bring. Again, we also include data collection and data analysis. This allows students to be able to really understand and hone their features here and their knowledge base, but also analyzing it, making sure not just here's the data, but what does that data tell you and what does it do in that stuff. So again, those STEM concepts really bring in that knowledge and that learning into your classroom. So the next one we have is a measurement math kit. This is another great STEM feature here that allows you to learn the different functions of measurement math. So there are a lot of different math opportunities out there, but do all your students come with a same general knowledge of things like how to read a tape measure, how to read a caliper, how to do fractions, how to do decimals? You know, sometimes the question is, you know, what do you need to know? And in this case here, all these different things are stuff that you probably get in a regular math classroom. All right. And the picture here, they always, give you these samples of uh that guy who buys 50 bananas and then they go and they eat 20 of them. What is the remaining of them? Or they split them up in different groups. What's the remaining of it? So the questions sometimes don't always have that real world analysis. What we like to do is bring that real world analysis into it. So we bring it into hands-on chunk sized learning here. So in this case, we walk you through the different standard ruler and then also metric pieces of it. All right, what are you going to be able to understand and know? And once you've learned that, now we go into caliper and the different types of calipers. And then we bring it into, again, bite-sized pieces where we have versions here for conversion rate, for metric of standard. We go into fractions. We go into decimal, both adding and multiplying and dividing. We then do the same from decimals to fractions and fractions to decimal, combining measurements together. And then we do a ton of real world practice and assessment, allowing you to try this over and over again. So The way we do that is through multiple modalities where we have in-classroom instruction, we have online instruction, and we also have student workbook activities, allowing students to go through different lessons on how to read a measuring tape, how to read a ruler, how to read a caliper, and then also conversions and then using it. So our student workbook has tons of questions, both online and paper-based, allowing your students to be able to interact with and then learn all the different features. And we have over 300 different measurements that they can do in that work. The last one that I want to talk today about is our electrical wiring kit. This one really features a connection point with hands-on learning and some very big STEM science and math concepts, understanding Ohm's law, understanding what's going on and how to do actual wiring, but learning a lot of different science concepts in the same time. So in this case, the components here, whoops, excuse me, components here are our wall panel demonstrator. You have all the different components to wire up 15 different types of residential wiring. And then we have a electrical wiring assessment kit that includes an assessment tool that allows students to do the wiring, plug it in with battery powered, so it's all DC powered, and then be able to see if they did it correctly or not without any opportunity for shock or electrocution of any kind, allowing students then to really understand did they do it correctly because our assessment tool will tell them if they did it correctly, if they didn't, and what do they need to do to correct that issue. So the other piece here is our um, ability for students to go through many different levels of wiring. So in this case here, here's a visual for you of one of our exercises where they have to do a power source, a ground wire, they have to do two switches and a light. And so all those different things, a three-way switch, a light, a power entry, and then both switches connected as well. They can go through and wire all this, making sure, did I do it correctly? Did I wire the things that the way they're supposed to? And then they can assess at the same time. Then they also learn through the different understanding pieces of how the electricity works, how it goes through the grid, how it gets to the home, how it is used, and what kind of voltage and transmitters are used to get to that place. We also then focus on, the panel itself, working through a breaker panel. What does that mean? Where's all that uh, um, uh, electricity going? How does it get transferred? How does it move through your house? And then we get in depth on a wiring diagram, really focusing on how to do wiring correctly and how to follow code. That all allows students to get the concepts of a real life learning experience, do it in a simulated way, so then they can get that understanding and that knowledge in the electrical wiring world. We then walk them through different exercises here, one after another, allowing them to be able to continue to increase their level of difficulty, starting with a single switch, starting with a single light, working all the way up to some very difficult different types of exercises in that world. So with some of those products, with the idea of everything that you do could be brought in within CTE, could be brought into a formula, a methodology of asking questions, getting into a engineering design process within your classroom. When we say what is STEM, it might be that CTE education is STEM and STEM is CTE education. We are teaching and using STEM to create next generation learners. That would be the statement that I would hope that we move forward within education, that CTE is bringing STEM into every single classroom, and every single classroom has aspects of what STEM education is. We can talk through, we can use the engineering um, design process to help students think about how do they create their products or their learning, how do they understand their learning, how do they interact with their learning, really helping students in that world. So again, what can we do? Well, the whole focus here and the hope in this session is to create learning like we designed it that way. getting the engineering design process, getting students to explore, design, create, try it out, all involved with every type of learning they do, and bringing that in, because then those standards that are included in your classroom, not only from what standards you hit in your CTE career clusters, um, but also the standards of, hey, we hit a lot of these STEM standards in the everyday activities that we do. So with that, I want to say thank you for taking the time with us today to be able to go over this idea of how we can create STEM and CTE together and bring it together. Again, here is that code that if you have the time and you would like more interaction with a local Realityworks account manager to help you with your program, help you work with your program, all you have to do is take your phone, scan this right now on your computer or where you're watching this, and you'll be able to link up and interact with that. So, with that, it is time for any questions that you may have, and be happy to answer any questions.
All right. Thanks, Jamie.
Mhm.
Couple questions are rolling in here. First question, does the curriculum included in the RC Tractor align to any national standards?
So yes, we have aligned it to both some of the agriculture, ag education standards, but it also has next generation science standards that it aligns to. So it also hits the next generation alliance standards. So which really connects with that. That STEM side, and then we also within CTE some of the STEM standards that have been created um, for uh, common technical standards, we also have it aligned there. So there's kind of three different areas that we've been able to focus the alignment within the RC Tractor.
Perfect. And another question, is the electrical wiring kit suitable for classroom and individual learning settings?
Yes, that's a great question. That is something where, yes, it is useful, or it's kind of two ways. It allows a student to go through individually and be able to walk through each step, each exercise, and then see if they did it correctly. If they didn't, the um, assessment controller will tell you what you did wrong and how to fix it. And so then you can redo that. So it can be a self-paced, individualized focus there. Now, at the same time, it is something that can also be used where you have a group setting where multiple students are working together for the same outcome, working together to see the different parts and pieces. And there's multiple places that you have to wire it up. So you could have multiple students doing the wiring, seeing if you did it all together. So yes, it has multiple opportunities there for usage.
Perfect. Well, I'm not seeing any more questions rolling at this time.
Okay. Well, thank you everyone for your time. Again, if you have other questions, feel free to reach out to RealityWorks. We'd happy to help. Um, go ahead and email me, talk to me. I'd be happy to help you get the the other questions you have, or work with you as we feel that CT and STEM are so closely aligned that it can work there for you as well.